think I forgot to hit record when I started doing this. So I'm just going to get you to look at the answers. And you can see question number 1, 18 moles of NO is how many particles? So I set up my map, moles to particles, set up my conversion here, got the correct number of significant figures. Number 2, what is the molar mass of CCl2F2? When I ask you this question, I want you to show your work. When I ask you specifically for molar mass. So I did my C's, my Cl's, my F's. There we go. There's my total molar mass. Number 3, how many moles are there in 987 grams? So we're going from mass to moles. We use our molar mass. How many moles are in 987 gram if 1 mole has this much? Set it up, work it down. Number 4, molar concentrations. There's 2 molar concentrations. So you can see I put my concentration as moles per liter. I put my moles on the top and my volume on the bottom in liters. Had to convert it to get that to the correct number of significant figures. Rounded it to 1 significant figure because that guy's 1. Next one, 0.75 divided by 0.065 to get 12 mole solution. Then I start on number 6. The first one was a mass to moles. So we had our mass, we're figuring out our moles, so we use our molar mass. How many moles are 124 if 1 mole has this? We're getting on to number 7. Number 7. What is the mass of 2.5 moles of H2SO4? Number 7. So we know our moles. And we're going to our mass. And we do that through our molar mass. And our moles are 2.50, 3 sig figs. And we're doing H2SO4, so we need to find our molar mass of H2SO4. H is 1.008 times 2, because there's 2 H's. Plus sulfur. There's 1 sulfur, that's 32.066. Plus, there are 4 O's, that's 15.999 times 4, 98.087. So we write it up. How many grams are in 2.50 moles if there are 98.078 grams in 1 mole? We do this times this. We round our answer to 3 sig figs. So 245.195, so that will round to 245 grams with 1 sig fig. That's number 7. Number 8. How many moles NO are there in 3.10 times 10 to the 25 molecules? So in this one we're going from particles to moles. And we use Avogadro's constant to do that. We start off with 3.01 times 10 to the 25 particles. And then we do our question. How many moles, right, because that's what we don't know, are in 3.01 times 10 to the 25 particles if 1 mole has 6.02 times 10 to the 23 particles. So we do 3.1 times 10 to the 25 times 1 divided by that. So in essence, we're just going to do 3.01 times 10 to the power of 25 divided by 6.02 times 10 to the power of 23. We get 50. So we get 50 moles exactly. All right, number 9. How many molecules of P2O5 are there in 7.32 moles? So we do number 9. We're going from moles to particles, and we do it by Avogadro's constant. We know that we've got 7.32 moles, 3 sig figs. So we write it up. How many I'm putting it down one. How many particles are there in 7.32 moles if there are 6.02 times 10 to the 23rd particles in 1 mole? 7.32 times 6.02 times 10 to the 23. .02 times 10 to the power of 23 close equals 4.406 and actually it should be 4.41 to get the correct number of significant figures, 3 and 3. So it should really read 4.41 times 10 to the 24 particles. Now that's particles of P2O5. That's how many of these molecules there are. Now how many P's are there? So the second part is how many P atoms are there? Well, every molecule has 2 P atoms. So we just take our number of molecules, and every molecule has 2 P atoms. So we take our number of molecules times it by 2. We get 8.81 times 10 to the 24 P atoms, because every molecule has 2 of them. All right, number 10. How many moles of nitrogen gas are there in 16.0 liters of gas at STP? So now we've got volume, and we're going to moles. Right? This is not concentration volume. This is volume. So we're going to use the 22.4 conversion. So what's our volume? 16.03 sig figs. So how many moles are there in 16.0 liters if 1 mole has 22.4 liters? 16 times 1 divided by 22.4. 16 times 1 is equal to 16 divided by 22.4. 0.714. Rounded to the correct number of significant figures, moles. That's it. That's number 10. Now, when we get to stoichiometry, you'll see how writing it out like this will really help you tell what's going on, and it'll help you organize your work nicely. I know it's pretty easy with these basic questions, but once we get to stoichiometry, organizing your work like this will be helpful. Number 11. If I have 340 milliliters of 0.5 molar and an NaBr solution, what will the concentration be if I add 560 milliliters more water to it? So, what are we starting with? We're starting with the concentration and a volume, and then we can go to our moles. And then we're going to go from our moles to our new concentration. So our first concentration is 0.5 m at 0.340 liters. So we can figure out how many moles there are. So let's do that. Moles is equal to, molarity is equal to moles per liter. We know our molarity is 0.5 is equal to how many moles we have per 0.340 liters. Multiply that out, 0.340 times 0.5. We have moles is equal to 0.17. and that's NaBr. Okay. Now, we know our concentration. Now we're going to add 560 milliliters of water. So down here, we are going to be, what's our concentration with 1 liter of water? What's our concentration with 1 liter of water? Well, let's do our formula again. Concentration is equal to moles per liter. So we know we're putting in this many moles, 0.17 moles, and now we have 1 liter of water because we've added 560. No, it's not 1 liter, silly Stein. 340 plus 560 is 0.9 liters. So we have 0.9 liters of water, right? Because that 0.9 liters is our 340 plus our 560 milliliters, 900 milliliters. So we divide that out. 0.17 divided by 0.9, 0.1888888. Goes on forever. Now, how many significant figures should this have? Well, this guy only had 1. So at the end, our final answer can only have at most 1. So our concentration is 0.2 m in 9.9 liters of water. So we did kind of a 2-step process there. All right, so let's look at number 12. It's going to be the same way. Number 12. If I dilute 250 milliliters of 0.1 m lithium acetate solution to a volume of 750 milliliters, so that's my final volume, what will the concentration of this solution be? So we start off with the concentration, and we go to a number of moles, then we go to a new concentration. Our first concentration is 0.10 moles at 0.25 liters. Now 2 sig figs in all of this, so our final answer should have 2 sig figs. In the end, we're going to have some concentration in a total of 0.75 liters. That's our total amount. So let's do our first one. M is equal to moles per liter. M is equal to, 0.1. Our concentration is equal to our moles per 0.25 liters. So our number of moles is going to be 0.1 times that is 0.025. 0.025 moles of lithium acetate. Now we're taking this 0.025 and it's going to be in 0.75 liters of solvent, so we'll figure out our new concentration. 0.025 moles in 0.75 liters. 0.25 divided by 0.75 is equal to 0.033. That keeps going on. We only want 2 sig figs because this guy had 2 sig figs. Everything here had 2 significant figures, so our final answer is 0.033 m. There we go. That's homework number 3. I hope this recorded this time. I hope this was helpful to you. I hope you understand how to do these questions and can do them on your own. Thank you for watching.